Friends, it's Jordy here, and welcome back to my now YouTube and TikTok series. I took the 20 videos I made on YouTube and put them all onto TikTok as well. And I thought what we could do today is to look at time series in the RStudio. Time series comprise about 20% of the data sets that I've worked with, and they can be over various timescales. They might be like per second, per minute. You might have hours, you might have dates, years, and months. So anything relating to time, and you've got measurements of a given variable, for each one of those time periods. We'll come to that in just a second. I wanted to just come back to the subject first of adding statistical results onto box plots. I did this in a couple of videos before, okay, and we used a library called ggsimplestats to put Dunn's pairwise comparisons, just significant Dunn's pairwise comparisons, i.e. where it's a p-value of 0.05 or less, onto box plots. You can use ggsimplestats for that, and that's great. And so let's just remind ourselves of what that looked like using Iris. As a reminder, a quick reminder, because I talked about this in a previous video, Dunn's pairwise comparisons goes together with Kruskal-Wallis. Okay, Kruskal-Wallis is a non-parametric alternative to one-way ANOVA, or analysis of variance. And so with Kruskal-Wallis, you can see if, or get an idea, if the different levels of the predictor are associated with a change in the response, even when residuals of the model do not meet the assumptions of parametric tests, okay, i.e. equal variances, normality, and a couple of other things. As a reminder of the ggsimplestats method of putting the lines, the brackets onto the graph, we can make a box plot first, okay? ggplot data equals iris AES. For this, we're going to use species on the x-axis, as we've done many times before. Okay, that's going to be a factor on the x-axis of a box plot. Y, let's take sepal length, okay? Remember that if you forgot what iris looks like, it's a short data frame, 150 rows, 50 rows for each species. The species column is factor, and the other 4 columns are numbers, okay? The numbers would go on the y-axis of a box plot. We need a line to tell R that it's a box plot, which is this, okay? And we don't need to add anything else in the brackets for that, because in the brackets we would do things like color, other aspects of size of the box plots if we wanted to, but it's still going to work without doing that. Then, as long as you have the ggsimplestats running, okay, which is this one here, then when you start typing this, stat underscore kw, it's going to suggest the code, which is going to add the lines onto the plot, okay? So we get this. And this is just 3 lines of code without doing any customizations of the general appearance of the graph, including of the scales or the labels or anything. Okay, so just to kind of remind yourself, you can make an okay graph just in 2 or 3 lines, but it's not what I would hand in, because I would change a lot about the appearance. Remind yourself that the middle lines in a box plot are the medians. But the thing that we're focusing on is these, okay, which is comparing each individual level of the species in terms of its sepal length. So this bracket here compares Setosa with versicolor. But this is only showing brackets where the p-value is less than 0.05. If the p-value was over 0.05, i.e. there was not a significant difference, you wouldn't see a bracket between the pairs by default. Maybe there's stuff that you can add within the brackets to show that in case of the p-values being non-significant. But in the default code, which is just this, it's only going to show lines where the difference is significant. In this case, we do have lines between every single species, okay, or levels of the species column. So therefore, all these pairs are significantly different to each other in terms of the y-axis, the sepal length. That's what we did before using ggsimplestats. I have recently come across the extra things you can do in ggpubr library, okay, which probably, if you look into it, gives you more opportunity and customizations for this kind of stuff compared to ggsimplestats, but I haven't looked into it enough. What I'm going to do for now is show you the basic code for ggpubr to make something like this. Okay, so what we would do is we would just firstly leave a hashtag to say ggsimplestats method, and then copy paste all of this into new lines. Make a second method, the ggpubr method. The first two parts are exactly the same. We're not going to need this because we're not using ggsimplestats. We're going to replace that with these two. And now I'm going to talk a little bit about what these two lines are doing. Again, they are part of the ggpubr library. This one is a stat Kruskal test. So basically, we haven't actually added into this ggsimplestats graph the overall Kruskal-Wallis p-value and test results. We were mostly focused here on adding the Dunn's test results. In this case, this code allows you to add the overall Kruskal-Wallis test results. So that's not looking at pair differences. That's looking at the overall model. The question would then be, what is, or is there overall, an effect of changing the species on sepal length, instead of looking at specific species? It's looking at the overall species column. This is the part that then does the Dunn's lines here, okay? A bit more to add to this because you need to add things like method equals Dunn's test. It starts off though with geom_pwc, and you remember that the geom part is about, kind of like a type of graph, as we did here for geom box plot, or we've done before for geom_point. That's why I suspect that we could probably do a lot more with this in the future, and I haven't really done that so far. But this probably has a lot of customizations associated with it. Okay, don't worry too much about the rest, but the first part here is to just add p-values, and the second part is the distance between the lines. Okay, you could probably run the code without that, and it will put a default distance between the square brackets. So let's try and run this now and see what it looks like. Okay, so one thing is that, in this part here, we've added the Kruskal-Wallis overall test results. What's nice about this is it's added the number of rows. As I said, that's 150, it's 50 for each species. That is a nice addition, and you're probably going to have to put that information into either the graph itself or into a caption, okay? So you might as well put it into the graph itself. The label.y equals 6 is the position of that line on the y-axis, and we don't want it to be 6, we probably want it to be 10, so that it's showing above the square brackets Dunn's test results. So let's put that to 10. and now you've got it above. So we're seeing, yeah, we're seeing the same kind of results here in terms of which square brackets are showing and between which pairs. I posted a photo of this on Facebook group the other day, and somebody said I would probably cut down the number of decimal places and like significant figures. That's something to do, you know. Maybe you don't need it to have this many zeros, because you could just do less than 0.001 instead of show all of this. So all of that I'm sure can be customized further by adding extra stuff in this part here. But I'm not going to do that because that just was to show you that geom_pwc in ggpubr, and again, like, see, I'll show you. If you start typing geom_pwc, this is only in ggpubr. This is not in ggplot2 or tidyverse. So you need ggpubr running for that. But if we can get to grips with what this can do, that could be very useful for future graphs. Alright, now I'm going to look at some time series stuff. And for the purpose of that, okay, I'm going to just go into a data frame that I created as a CSV file. And this is like the bare bones of a data frame that we can work with. Okay, now I just made this for the purpose of having dates in a column. We've got 90 rows. I've created 90 rows. There's 30 from zone A, zone B, zone C. And I've added dates in here according to the kind of British formatting for dates, which is day/month/year. I know that in America it's month/day, so that's also another way to present dates. What I'm going to do is bring this into R and then use R in order to create counts or a column of values that is associated with each date time in each zone. Okay. Incidentally, I haven't used, this is just to show you, you know, I haven't put the same dates in each zone. This is just a continuous date thing, so we can imagine that the people sampled first in zone A, then they moved to zone B, then they moved to zone C. An alternative way to do that, if you want to do statistical analysis, would be to have the same dates in each zone, and that's typically the kind of data I've worked with. But this is just to make graphs and to show you the code for doing some sort of time series analysis. In the end, we might not even really look at zone. Okay, so we got that. I don't need to save any changes to that, that's cool. And so we're going to don't save. Right, then we're back in here. And I'll put me back in my regular place. Okay, let's make some space here and let's read in the data. I've already set the working directory to that place. Okay, so it should find it when I type in its name. And then we're going to run this. We're going to view it and make sure that it looks just like it did in Excel/CSV. Yeah, it does. Okay. So that's our data frame that we're going to now improve, actually turn into something useful by adding a third column. Okay, we can use dplyr to assign random numbers. Random numbers in a new column. Okay, so let's make a data2 is based on data. As I've said before, this is my preferred way to make big changes to data frames. I copy them first, meaning that we could go back to the original if we wanted to, but we won't want to here. Now, what we're going to do is use mutate. So mutate is for creation of columns. And let's just imagine it's a counts column, huh? Accounts of something. Could be anything. Could be plankton, could be plastic bottles, could be people. Could be anything. So then we're going to do the word sample. And we know that there's 90 rows, okay? So we're going to put the number 90 in this, okay? This is going to assign random numbers to the 90 rows. The other thing we need is we need the range in which those random numbers occur, okay? So here you can just, in these orange brackets, you can do, like for example, 0 to 100 using the colon, then a comma, then 90. That's it kind of reminds me a little bit of the breaks in the scale y continuous, you know, where we assign the third number as the distance between ticks. It's a little bit like that. So here we've got 90 rows, and we're in those 90 rows, we're going to assign numbers randomly between 0 and 100 with the sample function. Okay, and now we're going to view that. And here we've done this. And of course, the next time you do this, the numbers would be different, okay, because it's a random sampling. So that's like a good way to kind of make up data, you know, and it's probably slightly faster to do it in R than it is in Excel. So we've got this data 2 ready to go now. Typically, when you want to present date-time data, or you want to present dates, you would do that on the x-axis of a graph, and you typically make a line graph. There are other ways to show time series, but most people would start with a line graph. Let's do a quick check, as we should do with any new data set, of the types of data in each column. And this is what I wanted to get to here. We will see what happens when we try to make a line graph of this. However, I'm already slightly concerned, because date time column, when we brought it in from Excel, has been assigned as a character. That's not really the ideal type of data that we want for dates. We want date data as .date. So when we brought it in from Excel, even although it looks like dates to us, R has not considered it as such, and that could create problems. Let's find out if it creates any problems. So we're going to make a line graph of this, and your line graph would be, of course, date time on X and the counts, the values column, on the Y. Remember that when I create columns, I typically put them in quotation marks. You know, it helps, and it changes the color to green, and it helps me to remember that that's a column I've created. If you can save time, yeah, copy paste previous ggplot code and change the parts that you need. So we'll have to change a couple of things here. Of course, we'll have to change the X and the Y, date, time, and counts. But the syntax will always generally be similar for ggplot. This one's a geom line instead of a geom box plot. Let's see what happens. Okay, so I accidentally made a mistake there and pushed return too early. There should not be a plus on your final line, of course. So we got this kind of major issue going on here. And we could try and see, that's not ideal either. You can try the solution to fix that we did before by putting factor in front of the x-axis and seeing what happens. But it still won't work. And your easiest fix to that, again, is to turn the character into dates. So let's do that. to turn that date column, or make a new date column, which is dates in date style, date format instead of character format. And so we're going to use our old-fashioned mutate again to do that. And mutate changes things. You know, you can use the old base R version to do like as.date as well, but we're going to do it within dplyr and the mutate function. So let's make a date2. This is going to be based on the date time column. Incidentally, the I called it date time, but there was no time in it. It was just dates. Okay. I think previously I was going to use time as well in the date time column, but there isn't any at the moment. Okay, we're making a new column, as you remember from the green quotation marks. And you've seen me do this before with as.factor and stuff like that. As.numeric. This one is as.date. Then an str afterwards will show us what changed. Alright, in the orange brackets you're going to need date time, the original column that we're changing. And then you need something else, which is the format for the dates that you're making. Okay, and you can use whatever format you want, like whether it's British style or American style. If we go with the British style, because I am in Scotland, we're going to do this, right? %d slash %m slash %y. And that means that we're going to follow or use the same format that we already have. Which is, let's see, date, day. This is 1st of October 2023. Day first, month second, year last. You don't need to put like Y 4 times because there's 4 numbers assigned to the year. It's still going to work as it is. This is lubridate, by the way. So this part here is lubridate, which is part of the tidyverse package. So we could do that as well as dplyr, all because we have tidyverse running. Alright, let's run this and see what happens now. We can view it, but that's probably less interesting than doing an str, which we'll do in a second. Okay, it did change the format, and you notice that it put dashes instead of forward slashes in the new date2 column, which is cool. And this kind of looks pretty good because we go up to 30th, and then that's the last day of November, and then it starts in December on the 1st. So we got it right in terms of the format. Now, what we want to do is do an str on this and check the type for the date2 column. Now it's a date format here in this format, so this is good. So hopefully now, if we copy paste the line graph code and make the X now date2, it'll fix the graph for us. And I'll put date2 in the hashtag as well. Don't forget, you can ask me for the scripts and I will send them to you, privately. Also, don't get confused about the difference between data2 and date2. Data2 is a data frame, date2 is a column. Just happens to be named a similar thing. Okay, let's see. So we're going to change this, my bad, to data free, because that's the data frame this is coming from. And now we've got a line graph. And that worked. Not only has it fixed the previous graph, which just didn't work at all, it's actually done this nice thing on the x-axis where it's turned all of these into months. Okay, so it's taken the dates here and it puts them on a kind of continuous scale starting from the first date to the last date and writes the month names, which is cool. So that's kind of already a good start. Turns out, looking at this, that it really looks random. Maybe your data won't look so random when you use this approach. What I wanted to do quickly is to expand upon that using a library called ggtimesseries. Okay, ggtimesseries, it's got a capital T and a capital S. Let's first uninstall ggtimesseries, because this is one that we might have to get using install_GitHub and the remotes library. So I want to just show you that. If we go into install, okay, and we type in ggtimesseries, it's not showing up, okay. I know for a fact it's got a capital T and a capital S, but that's still not working for this new version of R. We can confirm that. I mean, you'll just, it seems to already want to tell me I've still got it, but I know for a fact you can't get it for this version of R through the install button, through the packages tab. So what you want to do is you want to use remotes and then this install_GitHub. This is from GitHub. Okay, firstly, you remember, as we saw before, that it always gives like the name of the developer / the name of the library, and it's that information that you want to put into the quotation marks. You can do that for any library package which is downloadable from GitHub, okay, and then it gets it for you. So that's great. We've got it now. And with that, what you can do is you can make your time series look a little bit more interesting. And that's just a simple case of taking the original code that you made with your line graph and adding some extra stuff here. Okay, one of the things I like is this one, stat_waterfall. So this is what our previous graph looked like. If you add stat waterfall with the ggtimesseries library, you get this. And this is really reminiscent to me of like stuff on TradingView, market prices, ups and downs, because that's what it is. Green is going up, is the counts increasing, and red is the counts decreasing. Once again, that's with stat waterfall. And you can also do stat occurrence within that library. This one's probably not as useful. Okay, stat occurrence. Check for other stat underscore stuff as part of ggtimesseries. That's going to show, yeah, it would show presence absence data, you know, because here we obviously have nothing for this date and there's no black circle. So that can be useful, but it's probably not as useful as a line graph anyway, at least in this case. Alright, then the last thing I want to show you is these two libraries, cron and make_r. Again, this one, make_r, might not be available instantly within the current version of R 4.6.0. Get that from GitHub as well. And once you've got it, you can hashtag that line out. Okay, I'm going to just focus now on what this can do. We're going to be using data free, and you notice here that it's got $signs, right, which is an old code type, you know, within base R. So I don't really use $signs too much anymore, and I tried to get away from that, you know, by using dplyr, and you can for the most part, but this code here requires you to use the $signs, so we're using them. The date column that we're interested in here is date 2. So it's, as you remember in this old code, name of the data frame, $, name of the column. I put this in because this is what you find on the internet about colors for this. This is number of colors and the color scheme, color palette. This has potential, okay, but as you'll see in a second, it's not perfect for the data set that I created here, okay. However, it is good for if you've just got a few days. And specifically, if you're interested in differences between Sunday, Monday, Tuesday, Wednesday, etc., this can actually be really useful for, let's say, interday differences, maybe within a week, rather than the multi-year data that we've got. Because with the multi-year data and multi-month data, it's kind of messed up the graph. I don't know why this is 2020. And we have all these kind of empty whites here. So it's not ideal for our data, but it is useful for shorter time series, perhaps, than what we've made here in this graph. That's all I'm going to talk about today. You could obviously do a lot more with time series in terms of the stats that you could use to analyze them. I like this one though, because it's exactly the kind of graphs that I look at for trading purposes. You know, I look at this price action stuff, prices, to see how things have changed over time. You can also, don't forget, you can also do forwards forecasting, okay, to predict what the price or what the accounts would be at a time in the future, based on what it's been at time in the past. This is how traders make money. Well, I'll leave it there, and I hope that was useful as a start, a kind of brief intro into time series. Let me know if you want me to do more with that. Otherwise, let me know in the comments what else you'd like to see. Have a great day. Bye.